Today we are going to discuss about the first part of electromagnetics, that is electromagnetism, wherefrom you can expect one question as a minimum, and there were occasions in previous EAMCET papers you can find two questions given from the same chapter as well. Before taking up the topic as usual, let us take up some of the important formulae of this particular chapter. We have in electromagnetism, majorly we have four different concepts like right hand thumb rule, Maxwell's corkscrew rule, Ampere's swimming rule, and Fleming's left hand rule. About all these four you people might have already discussed earlier. The direction of magnetic field produced due to the passage of current through a conductor that can be identified by taking these particular rules. One thing you should understand, right hand thumb rule application is very common. When we stretch our hand like this, and if you show the direction of current along your thumb along the direction of current across the conductor, the direction of your curled fingers, they used to provide you the direction of magnetic field produced. That is the concept. Based on this one, the first formula we have to remember is regarding Ampere's law. In fact, you know very well, while talking about Ampere's law, two applications we take. One, in the case of a finite conductor, that is finite long conductor. You people should understand, finite long conductor means what? The conductor of which the length should be known to you. Then the magnetic induction at a particular point which is at a distance r from the conductor carrying a current, that is equal to mu naught by 4 pi into I by r into sin alpha plus sin beta. This is actually the formula. What is what out of it you can all understand. If this is the conductor, this is the point considered, this is the current passing through the conductor, this is the distance r we take, this end you join with this end you join with this point, this angle you take alpha, this angle you take beta. So this formula is valid for this. If you take by any chance for infinite long conductor, infinite long conductor means the conductor of which the ends are not going to be seen. So such a conductor, what you will be finding is alpha is 90 and beta also is going to be 90. Then we can understand sin 90 plus sin 90, that is 1 plus 1 2. 2 getting cancelled in 4 twice. Therefore B will be mu naught by 2 pi into I by r. That is the formula. So as far as Ampere's law application that is concerned, we need to remember two formulae. One is for a finite long conductor, one is for an infinite long conductor. So this is one. Coming to the next one, what is this Biot-Savart's law? In fact, we know when we are finding a conductor of irregular shape, a small element of length dl you consider, it is now carrying a current I. The direction of current at this particular element is along the tangent. Now if you take a point over here P which is at a distance r like this, and if the angle made by the direction of current with the line joining the element with the point of consideration P as theta, then magnetic induction can be taken mu naught by 4 pi, that is I dl sin theta divided by r square. This is the formula. Based on this one, of course, we have a wonderful application. One is, there is a circular current carrying a coil. It has got n turns and it is carrying a current, say I like this. This line whatever is passing through the center of that circle, that's called axis of the coil. On this axis from the center at a distance say d, there is a point we have considered as P. What is magnetic induction at this particular point P is the question. For this the formula is mu naught by 2 Ni r square by r square plus d square whole power 3 by 2. This formula you people have to remember as an application of this. There is a special case in this one. What is that special case here? At the center of the coil, they may ask you, at the center of the coil means you can understand distance will be 0. Then what happens to this formula? B is equal to mu naught by 2 into Ni by R you will be getting. So this is the formula you have to take up at the center of the coil like this. Coming to the next one over here. What is the force experienced by a charge in a magnetic field? The force experienced by any charge that is entering into a magnetic field with a velocity v, making an angle theta with the direction of the field, the formula is BQV sin theta. This is actually the formula. But all of you should understand, if sin theta, that is theta is either 0 or 180, then you can all understand, well, sin theta is becoming 0. Then what will be the force thereby? That will be minimum and its value will be 0. What is the maximum value of this? If theta becomes 90 degrees, then of course the force becomes maximum and its formula will be BQV. But one thing you should understand, the moment theta is 90 degrees, the path traced by that particle will be circular. When it is moving along a circular path, what is the minimum condition? Centripetal force must be equal to centrifugal force. Then how to write that equation? BQV is equal to mv square by r. This is the centripetal force caused by the magnetic field applied. This is centrifugal force, that of course is a pseudo force or a fictitious one. V getting cancelled. You can write this one, r is equal to mv by bq. This is one formula. You can even rewrite the same thing this way. mv is nothing other than momentum. Root of 2m into kinetic energy divided by bq. You can write like that. That itself you can even rewrite it like this also. 2m into qv, v is a potential difference, by bq. So these are the different other versions of the same formula you need to remember. So this is one more formula that one has to take up before entering into the applications part. Look at the next one. What is the force experienced by a current carrying a conductor placed in a magnetic field? The formula for that one is BIL sin theta. This is actually the force experienced by a conductor carrying current when placed at an angle theta with the direction of the magnetic field as such. So this is one more formula. What is the torque that is acting on a coil suspended in a magnetic field? You can all understand this one, BIAN cos theta. What will be this theta here? Angle made by the plane of the coil with the direction of the field. That of course you can say, when theta is 0, that means you can definitely understand cos 0 is 1, then naturally torque will be maximum. When theta becomes 90, then cos 90 will be 0, then automatically torque will be minimum. So based on the same concept, you have taken up one more galvanometer. One is of course a tangent galvanometer, we know. This tangent galvanometer is based on tangent law. And what is the formula? I is equal to k tan theta. What is this k called? Either Tg constant you can call that, or else you can call the same thing as that reduction factor of tangent galvanometer. Then what are the two formulae you have to remember? I1 by I2 is equal to tan theta 1 by tan theta 2. That is one formula when k is given constant. Otherwise, k1 by k2 is equal to tan theta 2 by tan theta 1. This is the equation when I is given constant. So two things we have to remember. Likewise, there is one more galvanometer, that is what of course we people used to call it as moving coil galvanometer, MCG. What is the formula for current over there? C by BAN into theta. That is the formula. What does this C stand for? It is the couple per unit twist produced in the suspension wire. B is applied magnetic field. A is area of cross section of that particular coil suspended in the magnetic field, and N is the number of turns. Theta is angle rotated by that coil as such. So this is the formula. But what is important most over here is theta by I. If you write, this is BAN by C, we can write it. This is what we call it as current sensitivity. This is the formula for current sensitivity. You have to remember, current sensitivity depends on area of the coil. Current sensitivity depends on number of turns in the coil. Current sensitivity depends on B, the magnetic induction of the coil. So these are all the points what you have to take up. And finally, how do we convert moving coil galvanometer into an ammeter? The conversion of ammeter, of course, you know, when galvanometer is shunted with a very, very low resistance, then that construction itself is called as an ammeter. Then what will be the current passing through the galvanometer? S by G plus S into I. That is the formula corresponding to that you have to remember. And S will be as low as possible. And at the same time, what is the resistance of an ideal ammeter? Resistance of an ideal ammeter is going to be 0. That is a point you have to remember. Come to the next one. When the same galvanometer is connected in series with a high resistance, that will now be converted into a voltmeter. What will be the resistance to be connected to convert this into a voltmeter that can measure V volts? That is V by Ig minus G. Ig stands for the current passing through the galvanometer and G stands for the value of galvanometer resistance as such. So these are the formulae overall one should remember before taking up the applications of this particular chapter as such, that is electromagnetism. So taking all these formulae into consideration, let us work out some of the applications based on this. As and when we find a new concept there, I will explain you that one then and there itself. Look at the very first question. If B bar is the magnetic induction at the center of a circular coil of radius r carrying a current is 1 Tesla. B bar is given 1 Tesla. Where it is given actually? At the center. So you can definitely understand B is equal to mu naught by 2 into Ni by R. This is given 1 Tesla in the problem. This is the formula at the center of the coil. What is the magnetic induction? Then its value at a distance of root 3 r on the axis from the center of the coil. So you can all understand, I write this one as B1 mu naught by 2 into Ni by Ni r square by r square plus d square whole power 3 by 2. This is the formula I said. What is the value of d now given? It is root 3 r it is given. Come on, substitute that one here. D square will be how much now? 3r square. 3r square plus r square, 4r square. Now you can rewrite the same thing this way. Mu naught by 2 Ni r square by 4r square and root whole cube. You can all understand 4r square root is 2r. 2r whole cube will now be 8r cube. So how much it will now be? Mu naught by 2 Ni r square by 8r cube. This r square cancels r times. So what is now left over? 1 by 8 into mu naught by 2 into Ni by r. Look at this one carefully. Mu naught by 2 into Ni by r. Already I have taken it as B and its value is given as 1 Tesla. So substitute that 1 over here. Now how many Tesla you are going to get? 1 by 8 Tesla will now be the value of magnetic induction. So 1 by 8 Tesla, that value is coinciding with second option in this particular question number 1. So the option for this one is second one. Look at the second problem now please. Look at that. A long straight vertical conductor carries a current of 8 ampere in the upward direction. What is the magnitude of the resultant magnetic induction at a point in a horizontal plane at a distance of 4 centimeter from the conductor towards south? The horizontal component of Earth's magnetic field is 4 into 10 power minus 5 Tesla. That is actually the concept. First thing you should understand is what are the directions, how to take them right now on the board. You can understand this is east, this is west, this is north, this is south. Now this is the wire carrying conductor. That current carrying conductor is perpendicular. Now east, west, north, south. It is carrying current in the upward direction. That means if you put your right hand thumb along the direction of current, this is the magnetic field that is produced. Towards the south, what is the direction of magnetic induction? Towards my right, because this is the direction. Here it is upward, here towards left, here downward, here towards my right. This is actually the value of B. But what is the direction of BH that is acting? Always BH will be from south to north. We know that. What is the angle between these two? 90 degrees. So if I take this as B and this as BH, what will now be the resultant field? It is root of B square plus BH square. That is the formula you have to adopt. But how do you calculate B? Mu naught by 2 pi into I by R. This is the formula for infinite long conductor. So you can directly understand mu naught by 2 pi is 2 into 10 power minus 7. Into what is the current that is passing through that one given? 8 ampere he gave. And of course, what is the distance at which he is asking you to calculate the field? The distance he is talking about is 4 centimeter. So write 4 into 10 power minus 2 meter. Now this cancels minus 5 times, 4 cancels twice. So what is left over? 4 into 10 power minus 5 Tesla. That is the value of B. But what is the value of BH that is given in the problem? Look at that in brackets. Again it is given 4 into 10 power minus 5 Tesla. Both are equal and both are perpendicular. Then what will be their resultant? It is root 2 times each of the value. That is 4 root 2 into 10 power minus 5 Tesla. That must be the answer. So what is the correct option over here? 4 root 2 into 10 power minus 5 Tesla is now coinciding with the third option for this question number 2nd. So third option is the right option for this problem, please. Look at the next number, that is problem number 3. The sensitivity of a galvanometer is 60 divisions per ampere. When a shunt is used, its sensitivity becomes 10 divisions per ampere. If the galvanometer is of resistance 20 ohm, the value of shunt used is how much? This is a direct concept of conversion of galvanometer into ammeter. Just now I have told you Ig is equal to S by G plus S into I. S is the shunt that is connected in parallel and G is the value of resistance of the galvanometer. What are the values given? You see, Ig now is going to be 10 divisions. And what is S to be calculated? G given 20 into what is I? 60 divisions he has given. So that is actually the conversion. Cut this 0 off. So you can write 20 plus S is equal to 6S. Then 5S becomes 20. Then what will be the value of S, please? It is 20 by 5, which now should become 4 ohm as such. So 4 ohm tallies with which option there? First option, that is tallied for this question number 3. So that is the answer for it. Look at the next problem, that is problem number 4. When two electrons enter into a magnetic field with different velocities, they deflect in different circular paths in such a way that the radius of one path is double that of the other. 1 into 10 power 7 meter per second is the velocity of the electron in the smaller circle of radius 2 into 10 power minus 3 meter. The velocity of electron in the other circular path is how much? That is the concept. Already we have discussed in theory, just now I have reminded you, whenever a charged particle is entering into a magnetic field, BQV, that is the centripetal force acting due to the magnetic field, that is equal to mv square by r, that is a centrifugal force. But in this particular question, if you look at carefully, q is that of an electron. Electron means q will be taken as E. So BE is equal to mv by r, that is the formula. So you can rewrite the same, r is equal to mv by BE. A little observation here makes you understand. E is the charge on the electron, that is constant. Mass is m, that is constant. That is, of course, both of them are entering into the same magnetic field. That is another point. So B also is going to be constant. So what is the only one which we are finding as a variable over here? Velocity. So velocity of the first electron by velocity of the second electron is equal to radius taken by first electron by radius covered by the second electron. But what has been given here now? Radius of the second electron is 2 twice the radius of the first, that is given. So 1 by 2 we people can write directly there. Now what is the velocity of the first electron he has given you? 1 into 10 to the power 7, that is 1 into 10 power 7 by V2 is equal to 1 by 2. That is actually the concept. So if you cross multiply this one, V2 becomes 2 into 10 power 7 meter per second. So this must be the velocity of the second electron which is tracing a circular path of double the radius of the first one. So correct option for this fourth problem is once again the fourth option itself, 2 into 10 power 7 meter per second as such. Look at the next problem, problem number 5. Two concentric circular coils A and B have radii 25 centimeter and 15 centimeter and carry currents 10 ampere and 15 ampere respectively. A has 24 turns, B has 18 turns. The direction of current are in opposite order. The magnetic induction at their common center or at the common center of the coils is how much? Such questions are very commonly asked models at different entrance examinations in general. So what one has to remember, you see, first I'll just draw two circles. Each one is a coil you take. They have common center. Therefore, they are called concentric circles. Fine. One I take it as A, one I consider it as B. Now see the radius of A, 25 centimeter. See the radius of B, it is now given 15 centimeter. Now currents in both of them are flowing in opposite directions, he said. Next one. A is carrying 10 ampere of current, B is carrying 15 ampere of current. A has number of turns, how many? 24 turns we have in A, and B, the number of turns in B is given 18. So this is the description. Now you should apply your right hand thumb rule here. See the direction of current here please. In this one, it is now anti-clockwise going like this. Now you put your thumb in the direction of current. Then naturally these four fingers are coming out as far as this point is concerned. So due to the first current, magnetic field's direction will be perpendicularly outside the board. Identify the direction carefully. For the second one, the direction of current is clockwise like this. If I put my right hand thumb along the direction of current again, this time the direction of current at point, magnetic field at point O is into the board. That means due to A, it is outside the board, due to B, it is into the board. When both the directions are opposite, you have to take the difference of those two to get the resultant magnetic induction there. So what is B now here? It is nothing other than B1 minus B2. That is the concept. What is B1 now? B1 is nothing other than mu naught by 2 Ni by R, Na Ia by Ra. You can definitely understand this is what is called B due to the first coil A. So how much you can write over here now? Mu naught by 2, the options are all given in mu naught only. Therefore don't change that. Mu naught by 2 into, what is Na here? 24. What is the current over here? 10. What is the radius of that one given? 25 centimeter, 10 power minus 2. You can write directly this way. Now what about this B due to B? Mu naught by 2 again, Nb Ib by Rb. So mu naught by 2 you leave it as it is once again. Nb, it is 18 turns. And what is the current? 15 ampere. What is radius? 15 centimeter, 10 power minus 2. Now you can simplify this one. In what manner? 240 here. 240 by 25. You can directly write this one. 2 times 5 you cut, 5 times 5 you cut. Now you can write this one mu naught by 2 into, this is 48 into 100. So 4800 by 5. You write this one as the first one. What about the second? You see 15 gets cancelled. This 10 power minus 2 going up, it becomes 1800. So mu naught by 2 into 1800, that will be this value. 4800 by 5, you cut this one, 9 times 45, 3 times 30, 930. So this is 1800, that is 930. Come on, just subtract one from the other. Whatever the value you people are getting over there, that you can take it over there. So what will be, which one is more here? The second one is more. Therefore, B resultant is equal to B due to B minus B due to A. Simply just write this value, mu naught by 2 into 1800 minus 930. Directly you can write it. 930 means, of course, how much it will be? It is already 800 here, 70 over there. So 870 mu naught by 2. 870 by mu naught, that 2. Cut that one over there, you will be getting exactly 420. That, of course, you will be getting the total answer 420 mu naught. That is actually the option for this. So which option is going to be correct for that? That is the third option. But be careful, if directions of currents are same by any chance, then you have to add both of them. As the directions are opposite here, you have to subtract them. One of the best model questions for EAMCET and other examinations is this one. Look at the next problem, that is problem number 6. Two tangent galvanometers are connected in series across a battery. In series they are connected means it is clear that current is same in both of them. The deflections in them are found to be 30 degrees and 60 degrees respectively. The ratio of their reduction factors is how much? Just now I have given you in tangent galvanometer, I is equal to K tan theta. That is the formula. So when I take I is equal to K tan theta equation, when I is constant, since they are connected in series, K is inversely proportional to tan theta. Then what to write here? K1 by K2 is equal to tan theta 2 by tan theta 1. What are the values of angles given? You see, first angle is 30 degrees. So tan 30 in the denominator and tan 60 in the numerator. So directly if you take tan 60 by tan 30, you are left with root 3 by 1 by root 3. 3:1 you will be left with. So what is the corresponding option over there? The third option is going to be correct for this question number 6, please. Look at the next problem, that is question number 7. A square wire each of side L carries a current I. The magnetic field at the midpoint of the square is. In fact, this type of a question can be asked in 3 ways. One, they can take a square. One, they can take an equilateral triangle. One, they can take a regular hexagon. Here we are talking of a square here. Observe the way we people are taking up the method. This is carrying a current I, even here also, here also, here also. You can understand well, this is going to be one of the diagonals. This is going to be the other diagonal. Then automatically this becomes the center. So you just join this end with the center, this end with the center. If I take length as L, what is this particular distance now, please? L by 2. Very simply you can understand. What will be this angle now? 45 degrees. What will be this angle now? 45 degrees. Now apply right hand thumb rule and identify the direction of magnetic field. If I put my thumb upward, magnetic field is going into the board at O. When I show towards my right, again it is going in. When I show in the downward direction, again it is going in. When I show towards my left, again it is going in. That means due to all the 4 sides, all the 4 currents, the magnetic field direction is into the board at the point O. So all the 4 fields are to be added up. So what will be the resultant magnetic field here? It is 4 times the magnetic field due to each side. What is the formula that is to be adopted? 4 times mu naught by 4 pi into I by R. R is how much here? L by 2 into sin alpha plus sin beta. Sin 45 plus sin 45. That is actually the formula. You just have to adopt. How many times? 4 times you have to take. That is the point. Sin 45 is 1 by root 2 plus 1 by root 2. 2 by root 2. That is nothing other than root 2. So root 2 if you take, 2 going up, 2 root 2 into 4 8 root 2 into mu naught I by 4 pi into L. See this option where it is given. 8 root 2 into mu naught I by 4 pi L. This option is tallied with the second option there. So, for this particular question, second option is the correct option for us. So, one of the excellent models and very, very important model for us. Look at the next problem, problem number 8. The magnetic field at the center of the circular loop shown below is, observe very carefully the figure what has been given, observe carefully the direction of current that is flowing across the figure. What is the direction you see? He is just giving us a loop like this. The loop is taken this way. Look at the direction please. Current is entering this way, it is going this way and going back this way. Like this it is going. Now you can understand this is the center. This radius is given R and current is given as I, no doubt absolutely in that. But you should look at this one as if it is a combination of two different conductors. What are the two conductors you are finding here? You see, one is a circular conductor of which this point is the center. One is a straight conductor carrying current of which the distance to that point is equal to the radius. So, two things we have to take. Now, for this straight conductor, I take the magnetic induction as B1. For this circular conductor, I take the magnetic induction as B2. But what are their directions you identify? Direction of current towards my right. My 4 fingers are showing that the direction is outside the board at the point O. Fine. What about this one again? When you are showing the direction of current upward again this way, again it is coming out. With both the currents, the directions are similar. Similar means what? You have to add these two. So, resultant B will be B1 plus B2. Now, tell about this direct value of straight conductor please. Mu naught by 2 pi into I by R. That is the formula for straight conductor. What about this circular conductor now? Mu naught by 2 into I by R. Ni by R officially, but number of turns has not been mentioned here. That means N should be taken as 1. So, you can write I by R. Now, just to look at this one carefully please. Mu naught by 4 pi he is giving in the options. So, better multiply and divide by 2. Then what will you get? Mu naught by 4 pi here. Here 2I by R you can take LCM. Common rather 2I by R. Now, what is left over here now? Here also you will be having 2. That means mu naught by 4 pi, 2I by R. Here you will be left with 1. Here you will be left with pi. That is the point. So, what will be your answer corresponding to this? Mu naught by 2 pi 2I 4 pi into 2I by R into pi plus 1 or 1 plus pi. That is going to be the first option for us in this problem number 8. So, only thing you should understand is the directions of currents and application of right hand thumb rule to get the correct answer for this. Look at the next problem, that is problem number 9. A wire of length L is bent into a semicircle and carries a current I. The magnetic induction at the center of the semicircle is how much? Directly you can apply the concept of a straight formula. Suppose there is a curve like this. This is the radius R and of course this is one end of it, this is another end of it. Current is entering this way and leaving this way, for example. If I take the angle made by this part of this wire as theta, then what will be the magnetic induction at the center? It is mu naught by 4 pi Ni by R. You can directly write into phi. What is that phi over here? This angle what it is making is phi. So, that is actually the formula you have to understand. Ni phi by R. That means what you people can write, in this particular case, it is a semicircle. Now, you can definitely understand this radius is R. What is this angle now it is making? That is 180 degrees. That means pi you can take up. Now, look at this one. If you take pi, that pi and this pi they get cancelled. What is now left over? Mu naught by 4 into I by R. Right? That is of course mu naught by 4 into Ni by R. But very carefully you should observe, in all the 4 options he is not giving r at all. Then what is to be written? Length is equal to semicircle, that is pi r. Then what should we write? R is equal to pi by L. That one you should write it here. So B is equal to mu naught by 4 into Ni by pi by L. Come on, directly substitute the values and you will be getting the value of second option, that is mu naught by 4 into pi into I by L. This is actually the concept what we have to take up. So what you will be getting here, R is equal to L by pi, L by pi. So pi should come into the numerator. So you can write L by pi. So pi goes up. So you will be getting mu naught by 4. N is 1. Therefore I pi by L. That is the corresponding option. So which option that is tallied there? The second option is the correct option for this question number 9, please. But remember this formula thoroughly. Mu naught by 4 pi Ni phi by R. That is actual formula. Look at the next one, that is problem number 10. A rectangular coil of a wire carrying a current is suspended in a uniform magnetic field. The plane of the coil is making an angle 30 degrees with the direction of the field, and the torque experienced by it is tau 1. You should understand immediately, plane of the coil is making an angle theta. Then what is the formula for torque? It is B-I-A-N cos theta. I have already told you all the other things are all constants now. Therefore, torque 1 is proportional to cos 30. That is what has been given there. And what else he said? When the plane of the coil is making an angle 60 degrees with the direction of the field, then the torque experienced by that one is torque 2. This is proportional to cos 60. I can directly write. Then what is the question he is asking? What is the torque 1 by torque 2? It is cos 30 divided by cos 60. Root 3 by 2 by 1 by 2. So what will be left over there? Root 3 will be left. That in the sense, what is the ratio? Root 3 is to 1. So second option is the correct option for this question number 10, please. But remember this formula thoroughly for the torque that is acting on a coil suspended in a magnetic field and carrying some amount of current through that. That is the point. Look at the next one, problem number 11. The coils made up of same material in 2 moving coil galvanometers have their areas in the ratio 2:3. Simply he is giving us few ratios there. Areas are in the ratio 2:3. That is mentioned first. What next? And number of turns in the ratio 4:5. N1:N2. That of course is given 4:5. Fine. These 2 coils carry the same current and are situated in the same field. The deflections produced by these 2 coils will be in the ratio of. That is actually the concept. What is the current? They are carrying the same current, he said. I is equal to C by BAN into theta. This is the formula for moving coil galvanometer. So what we can write? C is constant, B is constant, I is constant is talking. What is theta? Is proportional to A into N. So theta 1 by theta 2 can be written as A1 by A2 into N1 by N2. What is the ratio of A1 and A2 he has given, you see? 2 by 3. What is the ratio of N1 and N2 he gave? 4 by 5. So it should be 8 by 15. Then what should be the ratio? 8:15. That must be the very first option which is given over there as 8:15. Look at the option number 1, please. 8:15. That only is going to be the corresponding value for us. So this is the formula which you have to remember for MCG, which is moving coil galvanometer. Look at the next number, that is problem 12. A proton moving with a velocity of 2 into 10 power 6 meter per second describes a circle of radius r in a magnetic field. The speed of an alpha particle to describe a circle of same radius in the same magnetic field is how much? Already we have discussed, whenever a charged particle enters normal to the direction of the field, naturally it takes a curved path, that too circular path I said. So what is the formula for that? Centripetal force is equal to centrifugal force. That is the formula. But what is he asking? Speed he is asking. So first of all you can cut this one. Now automatically you can write R is equal to mv by bq. Same magnetic field he said, fine. But what else he said? He is talking about speeds differently. Same radius in the same magnetic field, R also is going to be the same. So can't you write from this one, V is proportional to Q by M, please? So you write V proton by V alpha particle is equal to charge on proton by charge on alpha particle into mass of alpha particle by mass of proton. In fact, every one of us we know charge on proton is 1 unit. That of an alpha particle is 2 units. Mass of an alpha particle is 4 units. Mass of a proton is 1 unit. So 2 gets cancelled twice. So you are left with 2 there. Then what is the question here? Velocity of alpha particle to trace the same circle of same radius. Then is it not velocity of proton by 2, please? What is velocity of proton given in the problem? 2 into 10 to the power 6 by 2. 2 getting cancelled. 1 into 10 power 6 meter per second should now be the velocity of alpha particle there. So what is the corresponding option? You check that one. First option stands with 1 into 10 power 6 meter per second. So this is the methodology we people have to follow when such model question is given in the exam. Look at the next number, problem number 13. Two parallel conductors A and B separated by 5 centimeter carry currents of 6 ampere and 2 ampere in the same direction. The point between A and B where the field is 0. First and foremost, you should remember 2 small points over here. Whenever 2 parallel conductors are carrying currents, say I1 and I2, if the directions are same, then there will be a sort of attraction between them. They used to attract, they used to come closer. If the directions of currents are opposite, then automatically there will be repulsion between them. So the force of attraction you will observe when the directions of currents are same. When directions of currents are opposite, then there will be force of repulsion. One thing you should understand in this case is the total currents, of course, what he has mentioned, you see, if I take this as A and this as B, this is of 6 ampere and this one is of 2 ampere. He said 6 and 2, fine. 5 centimeter is the distance of separation between them. That is actually the space between these two he is talking. Now, where the point will be now, at which the field will be 0. Field is 0 means what? Suppose if I take from the first one or from the second one I take, this is the point where the field is 0, which is at a distance x from B. Then what is the remaining distance over here? Is it not 5 minus x, please? Because total length is 5. This is x. So this will definitely be 5 minus x. Now, magnetic induction due to B at that point and magnetic induction due to A at that point, both are supposed to be equal and opposite. Then they get cancelled and the resultant field will be 0. That is the major idea behind. So how to write that one over here? I1 by R1 is equal to I2 by R2. Direct step. What is I1 here? If I take this one 2 by R1, that is x, is equal to, what is the other value over here? 6 by what is R2 here? 5 minus x you can take. This goes thrice. So 3x is equal to 5 minus x. So 4x is equal to 5. Then what will be x now? 1.25 centimeter. Where from it is 1.25 centimeter? From the second wire. So your option tallies with 1.25 centimeter from B. That means the third option that is correct for this question number 13. But be careful, if the directions are opposite, then this point lies outside that wire which is carrying the least value of current. Look at the next problem now. Problem 14. This is based on the same model. Two straight parallel wires carry currents of 200 milliampere and 1 ampere in opposite directions. If the wires are 20 centimeter apart, the distance of the neutral point from the wire carrying 1 ampere current is how much? That is the concept. Look at now the same concept with slight modification. This is the first wire. Now it is carrying 1 ampere current. This is now carrying how many milliamperes? 200 milliampere current. Now out of the two, which is the least? This one is the least. Therefore null point lies outside this wire carrying the least current. If I take this distance as x, then what will be the original distance of separation given? 20. Then what will be the distance from the second wire to that point, please? 20 plus x will now be the distance from this wire to that particular point. That is what actually we have to take. Once again, the magnetic induction due to the first wire at that point and magnetic induction due to the second wire at that point, if both are equal and opposite, they get cancelled and that point is said to be the neutral point. So how to write this one once again? I1 by R1 is equal to I2 by R2. Directly you take it now. What is I1 here? It is 200 into 10 power minus 3. By R1 you take it as x is equal to, this is 1 by what is R2 here? 20 plus x you take. Now in fact you can cut these two zeros with minus 1. This becomes now 0.2. So 0.2 by x is equal to 1 by 20 plus x. Come on, cross multiply this one. 2 into 2, 4 plus 0.2x is equal to x. Bring this one to the other side. 0.8x is equal to 4. X will now be simply 5 centimeter. So this is 5 centimeter. You can understand. But his question is, from here what is the distance? Is it not 20 plus 5? So what will be the distance over here? 20 plus 5, 25 centimeter must now be the distance from that wire carrying a current of 1 ampere. So fourth option is going to be tallied. So what you should understand, if directions are same, null point lies between the wires. If the directions of currents are opposite, null point lies outside that conductor carrying the least value of current over there. That is the concept. Look at the next problem, that is 15. A circular coil of wire of n turns has a radius small r and carries a current I. Its magnetic dipole moment is m. Usually magnetic dipole moment we people used to represent with capital letter M. And small letter of course implies that it is pole strength. So magnetic moment capital M, he is talking dipole moment. Okay, now next one. Now the coil is unwound and again rewound into a circular coil of half the initial radius, right? In fact, we know very well M is equal to NIR by 2. That is, M is proportional to R. So how to write this formula? M1 by M2 is equal to R1 by R2. Now what is R2 he has given you? Half the initial radius. So R1 by R1 by 2. This of course R1 getting cancelled, this will be left as 2. So what is M2 the question? Is it not simply M1 by 2? M1 how much he has given in the problem? It is given as M. So what should be your answer now? M by 2. Direct first option itself is the correct option for this problem number 15 as such. Look at the next problem 16 this time. A galvanometer has a resistance of 100 ohm. A current of 10 power minus 3 ampere pass through the galvanometer. It is converted into ammeter of range 10 ampere by connecting shunt resistance of. Already I have given you, I have briefed you the formula. Current through galvanometer Ig is equal to S by G plus S into I. S is the shunt value of resistance and G is galvanometer resistance. What are the values he has given you? You see there. 10 power minus 3 ampere, that is 1 by 1000 is Ig. S by, what is the G value given? 100 plus S into, what is the current he wanted to measure? 10 ampere directly. Come on, cross multiply this one please. 1000 into 10, 10,000 S is equal to 100 plus S. Bring this S this side. 9999 S is equal to 100. Then what will be the formula for S now? 100 by 9999 ohm. How to connect that one? It should be connected in parallel. That is the concept we have to understand there. So what is the correct option over here? First option is given 100 by 4 nines in parallel. That is the concept you have to take up. Look at the next one, that is 17. A galvanometer of internal resistance 100 ohm has a full scale deflection current of 1 milliampere. To convert it into a voltmeter of range 0 to 10 volt, the resistance to be connected is how much? Voltmeter conversion. Of course, we know the value of resistance required is V by Ig minus G. That was the formula I have told you. What voltage he wanted to cover now? 0 to 10. That means 10 is the total value. And what is the value of Ig? 1 milliampere, 10 power minus 3 ampere. What is the resistance of the galvanometer given? That is 100. So this automatically it goes up. You can certainly understand that one. So what will be the value here? This 10 cube into 10, that is 10,000 you are getting. Minus 100, 9,900 you are going to get ohm. 9900 what? Connected in series, because this is a voltmeter. That is the point you have to understand. Option is the third one, which is correct over here. Look at the next one, that is 18. There is one more problem based on the same structure earlier what we have taken. A wire is taken this way now. Current is entering this way, going this way, like this you will be getting. This is the center. And the radius over here is R. You can understand. Current that is entering is I. This is actually the description given. Now if you put your right hand against this current magnetic field is coming out of the point O. Whereas this one it is going in. That means both are in opposite directions, mind that one. So earlier whatever we have got, same value you get, but with a negative sign. So what will be your answer there? Mu naught by 4 pi 2I by R, till that extent common. Earlier what was the formula we have got? 1 plus pi we have got. Now it will be pi minus 1. So what is the correct option over here? It is going to be the second option, which is going to be true. So in this 18th question, the option for resultant magnetic field over here at the center is with pi minus 1. Suppose if the direction of current is going this way, it would have been plus. That is the only difference. Look at the next one, that is problem number 19. Two identical circular loops, each of radius r and carrying a current I, are arranged concentric with each other and in perpendicular planes. The magnetic induction at their common center is how much? You can definitely understand now. There are two coils. One is like this, one is like this. That is the common center. So magnetic field due to the first one, magnetic field due to the second one, both are equal to mu naught by 2 into I by R. But what is the angle between them? Angle will be 90 degrees. Therefore, resultant magnetic field will be B root 2. So mu naught I by 2R into root 2. Root 2 cancels into how many times? Root 2 times. So what will be your answer? Mu naught by root 2 into I by R. That must be your answer. Look at that one, the second option, mu naught I by root 2 into R. That is the correct option for us, the second option for this question number 19. Look at the next number, that is problem number 20. A moving coil galvanometer A has 100 turns and resistance 10 ohm. Another galvanometer B has 50 turns and resistance 5 ohm. All the other quantities are same in both the cases. Then voltage sensitivity of those two galvanometers is how much? In fact, we know very well current I is equal to C by BAN into theta. That is the concept of moving coil galvanometer. But I can be written as V by R. You can write C by BAN into theta. Now simply you write what is theta by V. Now you can write this one BAN by CR. This is what is called voltage sensitivity. That is actually the point. So what is he talking about here? You see, N is given, resistance is given. So directly you can take theta by V of the first one by theta by V of the second one is equal to N1 by N2 into R2 by R1. What is N1 of course given? 100. N2 given 50. So 100 by 50 it is 2. What is R2 given? It is 5. What is R1 given? 10. This is once again 1 by 2. So 2 definitely they get cancelled. So what will be left over? 1 you will get. That means both are going to have the same voltage sensitivity. So third option is the correct option for this question number 20 as such. Look at that one carefully once again. So see the next one, 21st. A proton is projected with a velocity 10 power 7 meter per second at right angles to a uniform magnetic field of induction 100 millitesla. The time taken by the proton to traverse 90 degrees arc is how much? A simple logical question. In fact, one complete rotation if it makes 360 degrees it is. 90 degrees arc means what? 1/4 the rotation it should make. How much time it takes? We know BQV is centripetal force. MV square by R is centrifugal force. Cut this. This MV, now you can write this one M into R omega by R. R gets cancelled. What is now left over? BQ is equal to M into omega means 2 pi by T. So what can we write? T is equal to 2 pi m by BQ. Now what are the values he has given? You see there. What is mass of that particular particle given? 1.65 into 10 power minus 27 divided by, what is the magnetic field given over there? 100 millitesla. Milli is 10 power minus 3. What is the charge on a proton? 1.6 into 10 power minus 19. After getting T, that is not your answer. You want T by 4 over there because 1/4 arc only it has to complete, 1/4 circle. So what will be the correct option for you? T by 4, 1.62 into 10 to the power minus 7 seconds you will be getting. This option tallies with the second option over here as far as 21st question that is concerned. Look at the last number in this order please. The scale of galvanometer of resistance 100 ohm contains 25 divisions. It gives a deflection of 1 division on passing a current of 4 into 10 power minus 4 ampere. The resistance to be added to it so that it may become a voltmeter of range 2.5 volt. Once again a simple conversion of voltmeter. R is equal to V by Ig minus G, that is the formula. So what are the values he has given you? You see there, G is given 100 ohm directly. What voltage he wanted to mention or measure? 2.5 volt. How to calculate Ig? Actually 25 divisions we have. Each division is 4 into 10 power minus 4. So what will be Ig now? 25 into 4 into 10 power minus 4 ampere. So this is 4 into 25 is 100. So 10 power minus 2 ampere, that is the value of Ig. So substitute the values over here. 2.5 by 10 power minus 2, that means 250 minus 100. So how much you will be getting here? 2.5 into 100 minus 100, that is the value. So what will you get here? 250 minus 100, which now becomes 150 what? Ohm. How do you connect that one? Should be connected in series. So what is the corresponding option over there please? Second option, that's going to be the correct option for this. So these are the different models. If you are a little careful in learning them and remembering them till the examination of EAMCET, it's going to fetch you not less than one question, and at times as I said 2 questions also they have given in the previous EAMCET papers as such. But in fact in electromagnetics part we have 2 more small topics left. One of course is electromagnetic induction and second one is alternating current circuits. Even from them also there is a possibility of getting one question.